Hello. In this video we're going to continue to look at Boolean operators, and we're going to look at the OR operator. So I have a little program here to help illustrate what we're doing. And remember, a really good thing to do is before running a program is to try and predict what the output will be. The reason why it's important to do that is because any external exam you sit and write, you are going to have to be able to read through code and state what the result is going to be. So it's good practice to do as a young programmer. It's something my high school computer science teacher always told me I should do. So don't feel bad if you have that tendency just to hit the run button. Okay, but moving on. So here we declare an integer a, we set it to 98, and we say if a is less than 100. Oh, a is less than 100, so it's going to come in here and print requirement met. And then this is an else if, so it's tacked onto that if, so we don't bother with this else if, we don't bother with the else, and we just finish. This entire chunk here is one large conditional structure, right? So now let's change this. Let's run it. Let's see, requirement met. Okay, let's make this 108. So now if I run this, a gets 108. Is 108 less than 100? And the answer is no. So it skips that first if and goes to the else if. Is 108 mod 2 equivalent to 0? Yes. So it goes in here and says requirement met. And so if I run this, requirement met. Let's make it 109. So a is 109. Is 109 less than 100? No. So it goes to the else if. Is 109 mod 2 equivalent to 0? No. So it goes down to the else and then prints out requirements not met. Ooh, and there we go. So again, we have this logic structure here that contains an if, an else if, and an else. But let's see if we can make it a little simpler using Boolean operators. So if I look at this, I see that it's going to print requirement met if a is less than 100, or if a mod 2 is equivalent to 0. So again, it's going to print out requirement met if a is less than 100, or if a mod 2 is equivalent to 0. So what that means is I can check both of the if and the else if in the same statement using my Boolean operator OR. So let's get rid of this, and let's put OR there. A mod 2 is equivalent to 0. And now we run this, requirement not met. I think another one we tested was 108. We run this, requirement met, perfect. 98, requirement met. 97, requirement met. Okay, let's put 109. Oh, we've already done 109. Let's put 111, shall we? Requirement not met. Okay, so you get the idea. We can condense these logic structures using these and or operators, and you can string them together. And with practice, you start seeing little kind of tricks and subtleties and ways to take what seems like a really complex problem and shrink it down to a very small number of conditional statements. So again, I just want to talk about one last subtlety which often students don't grab onto, but I'm going to mention it now. When Java evaluates an if statement, remember, when a Java evaluates an if statement with an OR structure in there, remember, either of those has to be true in order for it to enter that if structure. So here's the thing. If this first statement is true, is there any need to check the second statement? And the answer is no. And Java actually recognizes that. So Java will only evaluate the first statement if it happens to be true. So if I put the value, say 98 in here, and I run this, it will say 98 is less than 100, so this is true. So since this is an OR operator, it doesn't care about the second condition, so it's not going to evaluate it. Again, at this point, it doesn't seem like a big deal, but what you'll see is this little subtlety can help clarify some challenging problems later on. Anyways, I hope that helped. Good luck.